critical magnetic field strength in superconductivity. This is today's topic. So you know that to achieve the state of superconductivity, normal conductors can become superconductors under certain conditions. First condition is that temperature should be very low. It is close to absolute zero. Okay. Yes, room temperature superconductors are being developed and has already been developed by few scientists. Still researches are going on in this field. So under certain conditions, the property or the state of superconductivity can be achieved. This is known to you. And when superconductivity, this state is achieved, in that case, the conductor becomes superconductor. That means, in that case, it will have zero electrical resistance. Means no resistance. Okay. And in addition to this, there will be complete expulsion of magnetic field from the interior of the superconductors. So up to this is known to you. When the state of superconductivity is achieved, what happens? But there is one limit of the magnetic field. Magnetic field means magnetic field strength, which is measured in Tesla. Means SI unit is Tesla. So, what I want to say is that for attaining the state of superconductivity, first condition is you have to lower down the temperature of the superconductor by any means. And second is, when you are applying magnetic field over the superconductor, there will be complete expulsion of the magnetic field from the interior of the superconductor. But the external magnetic field which is being applied, there is a limit. Limit means upper limit is there. Yes, there is also a lower limit. Now we are talking about, in this video lecture, we are talking about only the upper limit. There is one upper limit. If you go above that limit of the magnetic field strength, in that case, the property or the state of superconductivity will be lost. The superconductor will become or will transition to a state of normal conductor. If you go beyond that magnetic field strength, and that magnetic field strength means the uppermost limit, the maximum value of magnetic field strength, above which the property of superconductivity is lost, is called critical magnetic strength. Yes, that is the today's topic. Critical magnetic strength. That property will be completely lost and the superconductor will become a normal conductor. So if you go below that temperature, then also you have to lower down the temperature of the superconductor. In that case, you will get the property of superconductivity. And as you go on lowering the temperature, the magnetic field, we are talking about critical magnetic field strength, okay? So this value of critical magnetic field strength will change. Means for a lower temperature, you will get higher values of magnetic field strength, for which the state of superconductivity will not be lost. So that means what? That means for the highest limit of the critical magnetic, means that is the actually highest limit, critical magnetic field strength. Okay. So for that highest limit, the magnetic field strength, means I am talking about the temperature, okay? For the highest temperature, above which property of superconductivity cannot be achieved. So at that temperature, there is one critical magnetic field strength. And if you are lowering down that temperature, then the magnitude of the magnetic field strength will be increased. That means I am talking about critical magnetic field strength. That will be increased. You will get higher values of critical magnetic field strength, for which you will get the property of superconductivity. Of course, there is one lower limit. So in this video lecture, I am not going to talk anything about the lower limit. For type 1 superconductors, for type 1, two types are there, type 1 and type 2. For type 1 superconductors, you will get a difference in heat capacity of the superconductor, which depends upon the critical magnetic field strength and the temperature. I should rather say that it depends upon the gradient or the rate of change of critical magnetic field strength with respect to temperature. So that thing I will provide you on screen. On screen you can see that relationship. Means there is a difference in heat capacity which depends upon critical temperature and critical magnetic field strength. A mathematical relation is there. Okay. So this was all about critical magnetic field strength. For type 2 superconductors, there is some difference. So in my next video lecture, I will talk about type 2 superconductors. Okay. Anyway, so this was all about critical magnetic field strength in superconductors. Thank you. Thank you for watching this video.